So we have lesson 14. This is day 2. We're going to continue with our examples. Yesterday, I have all the work erased already, but we found x to be 36.9 degrees. I'll put a little degree symbol in there because later on we will also be dealing with radians. Now, I think most of us should say, hey, wait a minute. If I know x is 36.9, I could find y really easily, correct? Just have to take 180, subtract the 90, which makes 90, and then subtract 36.9. So if I took 90, so y equals 90 minus 36.9, I end up with 53.1. Is that about right? Yeah. So I think that that's really simple. It's really easy because we know some properties about triangles. Well, in our homework tonight, and what I want to do for this work, the rest of our examples, I don't want that to happen. You can back it up. You can do this to say, hey, I know the answer should be 53.1, but let's do the actual trig work, get more practice on solving for y using trig. So, let's take a look at where y is. Y is at vertex A, or angle A, and I can use, what did we use yesterday? We used tangent? Mm-hmm. We used sine? Okay, we were going to use tangent. We used tangent, we were going to use sine. Okay, so we'll continue to use sine. I want to just use a different one than the one we had because I'll make sure that you guys understand they all work when the pieces are there. Again, the nice thing about this particular problem is all the sides are there so I can use them. So, sine of y is equal to, now since we are in our day here, let's just actually write down the ratio in words with opposite, adjacent, and hypotenuse. What is the ratio supposed to be? Sine. Sine is so. So it's so sohcahtoa. So it'd be opposite over hypotenuse. Now I asked you guys that when we're doing our first couple problems, at least till the next quiz or so, that you should probably write down those words. So where's the opposite? What side? 8. 8 is opposite. Adjacent is, oops, adjacent, and the hypotenuse is 10. So I asked you to do that. You really write it down once. You can use it, well, when you change angles, it's going to change. But hypotenuse will at least stay the same. So we're going to keep that the same. So that means that sine y is equal to, what's the opposite side? 8 over hypotenuse 10. Or we can just say, if you want to simplify this, 2, 4 over 5. Here's something that's kind of cool. Sine and cosine will never be bigger than 1. We're going to graph these graphs pretty soon. And you'll find out that the value of sine and cosine will never be over 1 when it's just sine y, or sine of theta, or cosine of theta. Okay, so remember, now that we have our ratio here set up, I want to solve for y. So I want to solve for y. I moved it over. Because I want to get y by itself, I need to get rid of sine. And to get rid of sine, I have to take the, what of both sides? Inverse. But the inverse sine of both sides. Probably should have left myself a little bit more room here. But I have to squeeze a little inverse sine above there. Because the sine and inverse sine, or inverse sine and sine, will cancel each other. Just like a square and a square root. They'll cancel. And so, that will leave me with just y equals the inverse sine of 4/5. And this is where you'd have to take your calculator out because they're not turning out to be nice angles. Now, there will be soon something called the unit circle that's coming up where you will have to remember all three functions, sine, cosine, and tangent. Remember the values for 0, 30, 45, 60, and multiples of 90. So all of those are going to be on that, and there'll be a way for you guys to remember that very quickly. Okay, so we put that on our calculator. I asked you to start bringing that every day because you're going to need them, trust me. And we end up with, make sure you're in degrees, 53.13 or 53.1. We got the answer that we said we should have gotten. So I would expect you to do it this way, the big circle there. You can do it this way to back yourself up with another method to say, hey, I checked my answer, right? And plus the fact that 53.13 plus 36.9 plus the 90 should add up to the 180. So it does not matter which function you're using, sine, cosine, or tangent you'll use, as long as you are given, for that particular angle, the actual sides to set up the ratio. Remember, when you use sine, cosine, and tangent, it's kind of like that distance equals rate times time problems. If you're given two of those three pieces, you can find the third one either by multiplying or dividing. The same thing works here for sine, cosine, and tangent. As long as you have the two of the three pieces, you can solve for any one of the one that's missing. So problem number 2, it says basically solve the triangle. Now, how many pieces do we need to officially solve for here?
2,
3. I got 2 angles and the hypotenuse to solve for. There is no hypotenuse. That's why we got to solve for it. Remember, right there stated above, to solve a triangle is find all unknown angles and sides. Even if it's not, it's listed. It's not telling us to solve for that. It's implied. Now, I'm actually going to solve for the hypotenuse right away using what? Pythagorean theorem. But I'm also going to show that you can use sine or cosine to solve for the hypotenuse as well. Okay, so we all know, hopefully, that a squared plus equals c squared, right? So I can say 5 is a, so 5 squared plus 15 squared is equal to c squared. 25 plus 225 is equal to c squared. 250 equals c squared, square root. I'm moving kind of fast on purpose, okay? We've done that probably about 100 times, it seems like, in this class. So, to make our life a little bit easier, I'll let it go to a decimal. So, someone take out your calculator. What's the square root of 250? 15.81 something going on, okay? 15.8 or 15.81 is fine. So, I'm going to go over here and write that, 15.81. We may have to erase that to make more room for ourselves. Now, we're going to solve for the hypotenuse using one of our trig functions and one of those other sides. But we can't yet. There's a problem. What's the problem? I have sine and cosine that both use a hypotenuse, right? But if I use that, I would have to know the angle, which we can call x or y, okay? I have to know one of those angles along with one of the sides to find that hypotenuse. Think of it. Look at sine. Sine says you need to know the angle, the opposite, and a hypotenuse. If those, okay, so the connection for sine is I need to know an angle, the opposite, and the hypotenuse. I need to know two of those three. Do I know two of those three if I did not have the hypotenuse?
No.
No, because I would still have the hypotenuse and an angle. Now, the reason I'm not going to use sine or cosine right now, because I do have 15.81, right? I have a hypotenuse. But is 15.81 really the true answer? No, it's an approximation. So, if I'm looking at this triangle, what's the only two pieces of information that I absolutely know? 15 and 5. Which means on one of those particular angles, x or y, I know an opposite and an adjacent. Which trig function fits that mold? Tangent. So I'm going to use tangent. Of what angle? Pick one. Pick one of y, okay. So we're going to go with y. Tangent of y equals the opposite, which is 5 over 15, which is adjacent. Or the tangent of y equals 1/3. Or to get rid of tangent, because we got to get rid of tangent, right? Is take the inverse tangent of both sides. Inverse tangent of both sides. So y equals the inverse tangent of 1/3. You're going to have to take out that trusty calculator. Make sure you're in degrees again. Callie? 18.4? 18.4 or 18.43 degrees. Again, y is not a very nice angle, but we know we have an approximation here. Now again, I could find x really easily while doing what?
No.
Subtracting it from 90.
Oh yeah.
So we can do that. Now, because 18 doesn't come out, or y does not come out nicely, we know that we're dealing with a lot of approximations. We can kind of use it. We're going to have to use approximations to find approximations if I want to continue to use trig in a way. I can find x using tangent as well, because that's opposite and adjacent, right? So could I find that if I do tangent of x is going to equal what? What's the opposite? 15 over 5. So tangent of x is equal to 3. And then I have to take what of both sides again? Inverse tangent. They cancel. And so x equals? Inverse tangent of 3, or what was that again? 71.56 degrees. And does it look like 18.43 and 71.56 will add up to 90? It's going to be super close, right? Remember, they're both approximations. We just used trig to solve for both x and y. That's what I was aiming for, number one. Number two, we found the hypotenuse by using Pythagorean theorem. Old school stuff. It works. It's awesome. What if I go up here? I'm going to erase the work for finding that hypotenuse real quick. Let's take that out of here. Okay. Let's solve for the hypotenuse using sine or cosine. So right now, we're going to assume we don't know the hypotenuse. Okay? But we're going to assume we know x or y. So, using x or y, let's do the sine of it. Which one do you guys want to do? Okay, we're going to use the cosine instead. So, we'll do cosine. Which angle are we talking about? No, which angle? X. So, it would be the cosine of 71.56, because that's the angle we're talking about, right? Equals, cosine again is? It's the
No, the Y.
adjacent,
Oh.
which is adjacent to 70, to x is 5,
Oh.
over, I'm going to call it h, because we don't know what the hypotenuse is. Let's say we didn't know what the hypotenuse was. So can I call it h for now? I know it just seems confusing. I'm just showing that we're going to get 15.81. Okay? So, on your calculator, now you can take 71.56 and take the cosine of it. What do you get?
0.31.
Point, what?
0.31.
31? 32, 31332 equals 5 over h. What do I have to do to both sides? Multiply by h. So now I got 0.32h equals 5. And now divide by 0.32. So h is going to equal, what is it? 15? 62. See how rounding, 6.3, 6.2, 6.3. See how rounding can change those numbers? This is why we generally try to stay away from using approximations to figuring out the new ones. Okay? So, 15.63, we know that the better answer would be 15.81 because we used Pythagorean theorem there. We didn't actually use approximations to get to that number. But again, I'm showing you that as long as I have 2 of the 3 pieces, we had to find an angle to get an extra piece to keep going. So it all works. So in this particular problem, I just want you to solve for x. But where is x? It's in the bottom, way on the far right there. It's part of a triangle, right? But is that triangle a right triangle? Because I got the 2 other sides to it. I got a 14 and a 16 and an x. That means if I had that be a right triangle there, well then I would know for sure that I could just use sine, cosine, and tangent and I have it. One thing I think they left off on here is I think we can assume this. So if I can assume that that's a right triangle, what can I do to solve for x? What's that? Solve for the big one. What do you mean? Solve for a to c. Can you solve for a to c right now? Yeah. Can you solve for a to d? Yeah. Can you subtract the 2? Yeah. Actually, you can just do this using Pythagorean theorem. You don't have to use any trig. Well, you know 10, right? That's, if you look at the very large triangle, that's 10, that's 16. Can you solve for the third side? Yeah. Then, if I break it into that smaller triangle, that's 10, 14. Can you solve for that small side? And then you take them and subtract them and you'll have x, right? But what if I said I don't want to use that?
Why do you have 10 for both?
Hold on. So I'm going to change my thinking on this one. I'm not going to use any trig on this one. I'm just going to use Pythagorean theorem. So if I go to the 1610, we know that we'll have 16 squared minus 10 squared. Yes? Which is what? We'll call this maybe we'll call this maybe what? We'll call it n. That'll equal n squared. Would you guys agree that 16 squared minus 10 squared could be equal to n squared? Just a rearrangement of the Pythagorean theorem without actually showing all of our work for that.
Why are we subtracting 10?
Because we're solving for a side and not the hypotenuse. 16 squared is 256 minus 100 which is 156, or n is the square root of 156. So we know this is 156 square root. You can reduce that, I'm assuming. I can divide it by 2. There might be some more numbers. Let's see what happens when I do the 14 and the 10. Same process,
Wait, why is it subtracted?
because we're not solving for a hypotenuse, we're solving for a leg. So I'd have to subtract a leg from the hypotenuse. 14 squared minus 10 squared equals, that's x this time. That's not x. That'd be what? Not x. I don't want to call it x. We'll call it m. So 14 squared is 196 minus 100 equals m squared. Or 96 equals m squared. Or m is equal to square root of 96. And what should I do with those two triangles? Or those two values? Not add them. Subtract them. These are all things that hopefully we should understand. We're using Pythagoras Theorem. That's all we're doing. We're just putting them together to form a problem that's a little bit more advanced. So that's square root of 156 minus the square root of 96. Oh, not the other way around. 96. It almost seems like you can't do anything more there. So you probably should take both of those and go to the dance with them. I'll let you guys do that. You guys should know how to do that. Remember that. So, I didn't record all the breakdown there going to the dance, but 156, the square root of 156 becomes 2 times the square root of 39. Square root of 96 becomes 4 square root 6. They don't have a common term, or they don't have a common square root. So our final answer, I'm going to write it inside a triangle, would become 2 square root 39 minus 4 square root 6. That's x. That's the exact answer. Now, if you took a calculator route, you'd come out with an answer that's a little bit more approximate. Last problem that we're going to do together with this is a man 6 feet tall is 200 feet from a tree, and he measures the angle of elevation to the top of the tree as 11 degrees. How tall is the tree? You may want to draw a picture to demonstrate this. So, him being 6 feet is very important because when we go to draw our picture, is the fact that we have this tree, okay? And we have this guy looking at this tree. He's looking at an elevation. He's looking up to the top of that tree, correct? And here's the thing, is that his horizontal to the ground is at his eyesight. Okay? This forms a right triangle. The whole idea that this man is 6 feet tall is that 6 feet is unaccounted for when you go to find the height of the tree. So that is important. Now, if we don't talk about the man, we just assume that this whole triangle goes all the way to the ground at that point. So we are trying to find h, the height. We know 2 other pieces of information. We know the angle on the way up is what? No, the angle. It's 11 degrees. And we know he is 200 feet away from that tree. Yes? Now, this is where we cannot use any particular function that we want. Maybe we should still write down. So, sohcahtoa. So we remember the ratios. We only are given one angle. We could find the other angle if we absolutely wanted to. Not needed though. So if I think of angle 11, what is h according to 11? It's the opposite. What is 200 according to 11? Adjacent. So which one does opposite and adjacent? It's tangent. So I'm going to use tangent. So I start with tangent of 11 is equal to opposite h over 200. I take my trusty calculator out and I do tangent of 200. Or wait, let's back up. Let's not do that yet. Let's leave it as tangent of 11 because you know it's not going to turn out to be something nice. How do I get h by itself? Multiply by 200. So 200. So I think everybody should agree that h will equal 200 tangent of 11. Yes? And now you can take 200 times tangent of 11 on your calculator. Make sure you're in degrees. What is the height of that tree? 38.87 feet, or 6, so 88 feet. Did we answer the question?
Yeah.
No, we didn't.
No.
There is something we have to take into account yet still. The 6 feet. Guys, solving for h, we did it correctly. Yay, we got that. But unfortunately, remember that the triangle is not accounting for that 6 foot of trunk on the bottom. So now I just have to add 6 to all of that, and you get 44.88 feet. That's what that 6 feet can do to you. If you forget that, you did all this stuff mathematically correct, but you just didn't finish the problem. So homework would be the worksheet. Have a great day. See you tomorrow.